object variants versus inheritance. Object variants are always stored in memory in its full size. Now, this allows object variants of an object to be stored in containers such as sequences. This also allows changing variants into other variants, which is not possible with inheritance. Inheritance. First off, we will import random module for later use. Then, under the type section, we will make the parent of inheritance called enemy I. So, type enemy I. Now, to enable inheritance, we need to type ref object of root obj, and then let's give it fields of x, y as float, and then parent enemy I. This will be used later on for proving dynamic dispatch. This will make it so that any child of the parent enemy I will be able to have a parent, and then when the parent object is added into a collection like a sequence along with its child objects, NIM will be able to determine which overloaded method statement to use at runtime when the program is running. More on that later. Now we will create the children, bandit I and wolf I, with attack moves as its fields of type sequence of the appropriate enumerator. So first off, let's make these enumerators. So humanoid attack moves, let's call it, is enum, and then for its enumerations, let's give him backstab I, eviscerate I. Then for the wolf, animal attack moves I, enumerator, and its enumerations, bite I and claw I. Now the two children, let's start with bandit I, ref object of enemy I, same as above, just not with root obj, which is required at the top level. So attack moves as a sequence of humanoid attack moves, and then the wolf. Lastly, wolf I is ref object of enemy I, and then attack moves as a sequence animal attack moves. Now here we're going to use methods over procs, because methods enable dynamic dispatch, selecting the appropriate function, proc, method, etc. at runtime when the program is running, instead of doing it at compile time with procs when writing our code. Methods require objects as parameters. Base methods should be base and as minimal as possible. In other words, the method using base pragma that targets the parent should be as minimal as possible. Base pragma is implicitly placed, but you should place it manually just in case. Pragmas in NIM are similar to the C programming languages preprocessor parameters. They are used to change the behavior of code to a different one. There are many pragmas in NIM. When writing methods, procs, templates, etc. that only have a short bit of code, we can write the code of that proc, method, etc. in the same line. Now let's continue with methods with that in mind. First, let's write methods as constructors for our parent of enemy I, bandit I, and wolf I. These constructors will be essentially useless because, again, methods require objects as parameters, so we can't give them the parameters we want to make creation of these objects via constructors easier. Object variants will be able to do that. So first, for the parent, method new enemy I, parameter b as enemy I, and then the return type, enemy I, and then the base pragma, like this, base. And then instead of writing the code of this method in its own line, we can give it in this at the same line. So instead of this, like this. Now the methods for the other two. Let's copy paste this entire line for each of them. Now we only have to change the names. So bandits, and then woof. Now we're going to make 3 methods for a hypothetical attack for all 3 objects. First off, again, as I said above, the parent object, enemy I, requires its attack method to be as bare bones simple as possible, because its functioning code will be to simply be a parent. Its child objects will have more functionality. So a simple bare bones method for the parent. Let's give a parameter name this as the parent enemy I return string. This will be just a hypothetical attack, so just string. And then the base pragma and simple value. Now the more complex method for both bandit and the woof. We're gonna copy paste it for both of them. So attack I, let's just copy this and change to bandits and remove the base pragma here because it's not needed here. This. Now we're going to use the randomize function. What this does is if you try to get a random number in any programming language that doesn't use this beforehand or internally, implicitly, if you don't do this, randomize the seed, if you get a random number of, let's say, 7, every single time you're going to run the program, it's going to give you that exact same 7 again. So you need randomize. Now, let's get the max field, or the last enumeration, the attack move. So this dot attack moves dot high. This is how we get it. And now here we will retrieve the result of this to get a random attack move. And we're going to need to convert it to string. So I'm going to start with string right here, because the attack move is going to be one of these enumerations, and enumerators are of type ordinal, and that is not string. So we want to get the backstab I and eviscerate I as the name, so that it's going to give it as the output into the console and not an error, because it's not gonna work. So this dot attack moves, and then for the index, rand proc to get the random, and then from the first one, which is obviously 0, to the max one, the last one. And now let's copy and paste for the woof. And all we need to do is change the name. Now, the reason we named all of these methods the exact same is that by naming a proc method and more with the same name, we overload that method proc. Overloading means that the compiler will determine which of the same named overloaded procs methods is to be used. Now we'll make a variable that will use the parent object of enemy I and a sequence to store 100 of randomly picked and stored bandit I and woof I objects. as well as the parent object, and then display that sequence. So first off, var overlord affix, so this code won't interfere with the code for object variants to compare to this code later on. Enemy I. Now the sequence, let's call it simply enemies. Enemies I as type sequence of type enemy I. Now we're gonna fill it with 100 random child objects of Wolf and Bandit. So for enemy in 0 to 99. Now let x to get the random value every time. So random 0 to 1. And now if it's 0, it's going to be Bandit, and if the value of x is 1, it's going to be Wolf. So if x is equal to 0, enemies I sequence dot add, then our methods to make it easier, but not for inheritance, only object variants. New enemy I, and then bandit object, and then for its fields x as e, and now we have to convert it to float because this random is only going to give us integers. So to float, and now the same for the y dot to float. Now the attack moves. Visual Studio Code is not correctly giving us information here, autocomplete. And sequence, okay, let's give it just backstab. And then the parent will be our overlord for that dynamic dispatch. Now let's copy paste right after this. Change everything to the wolf. So wolf, and attack moves will be different. What do we have? Bite I, and oh yeah, E. This is E to float, and like this. Now we're also going to store the parent variable into the sequence to satisfy the dynamic dispatch needs, requirements. So enemies.i.add overlord. Now let's display all these values and see what happens. For E in enemies I, echo E dot check I, and run this. Okay, so we got randomly selected 100 bandits and wolves and their attack methods being used to hypothetically attack. Now for object variants, we're going to write the above code with inheritance and methods into a version that uses object variants and procs instead. We're going to mostly copy paste what we wrote before, but without the inheritance part, like ref object of root obj, and change the affix of I when naming things into v for object variants, and not put the parent object into the sequence because it will not work, it will crash. First off, we're going to make under a type section a new enumerator. Let's call it enemies, so that we're going to use it for our two object variants. So in new bandit and wolf. Now we're gonna steal some code from above. this we're going to steal. And now we need to change all of the affixes of I into V. Not this one. This one needs removing. V, V, V. And also remove the inheritance part. Only need the object part. Okay, let's give this object its variance. But first, let's steal this code. Now, the case statement, case kind, and then enemies for its discriminator. Enemies, and then of bandit, its first variant. Copy paste this code, and he is humanoid, so that's fine. And let's just change it to V, and then of wolf, and copy paste this and to animal, and the affix into V. And because both of these variables are in the same object, we need to give them an affix. So B for bandit and W for wolf. Now let's create our constructors, which, unlike the ones we made and used for inheritance, will actually make the construction of our objects a bit easier. We can give them the parameters they require. So we will give them X, Y, and attack moves parameters, and return a completed object with the result variable filled with our parameters like this. So proc new enemy V, and then X, Y as float, and then A moves for attack moves of type sequence, and since this is going to be for bandits, humanoid attack moves V, not I, and then return type will be enemy I, since all of this is actually enemy I, enemy V, I mean. And now for the body, result, and we're gonna return the type enemy V. Now we gotta fill in the data, so X is X, Y is Y, kind bandit, attack, oh wait, bandit, attack moves B as A moves, and now copy paste for our wolf, and we change humanoid to animal attack moves. This remains the same, and wolf here, and attack moves wolf to A moves. Now we need to make a proc that does what the two attack methods did for inheritance. So instead of using two methods with object variants, we can simply use a case statement instead. So let's go up and copy this, paste it down here. We need two of this for the wolf and the bandit. So let's first change this to proc, and this will be enemy I V, and then use the case statement to discriminate case, and use this variable, this dot kind, and then of bandit will be the first one. Then we indent this code and add the bandit affix, because this is for inheritance one. Now for the wolf, of wolf, indent, and add the W affix. Don't forget to change all the affixes. Now we make the sequence, fill it in and display it like before, except that we won't be adding the base object variant enemy V object without the kind field specified. because it will crash our program. You can't mix the base object with its variance. Now let's go steal some code from above. Copy paste here, remove the parent. Now put a bit of v-affix thing here, here, here. Don't need this part, don't need the parent anymore because it will crash. And this is all good. Here, here. Now for the constructor, which is actually helping us this time around. So we don't need the data object type here, nor we need the field names, so we can remove all of that. Same with attack moves. And obviously the parent, which is useless now. And backstab and right. Now let's run this. And here we go. Object variance version. Child A to child B conversion. Both object variance and inheritance allow for variant to base and child to parent and vice versa conversion. But only object variants allow for variant to variant conversion. Inheritance does not allow this. Variant to variant conversion. Now I will demonstrate this with a simpler than above example like this. So here is the enumerator for the case statement. Variant enemy is the name, and the two variants are outlaw and spider, with different field names for easier discernment in the terminal. So here I initialize them both simply with the kind to make the variants, of course, without unnecessary x and y. And here is the conversion. Simply variable o, as in outlaw, takes the value of variable s, spider, and then we echo it. Now, before I echo this, by running the program, I'm going to cover the variant to base conversion as well. So here I simply make variable b, and by not giving it any values fields to fill in, it's going to make the base version, of course. And then we echo it, and here we change it to the spider and echo it. So now let's run this. Here we go. The first line is after the variant to variant conversion. So first we had the outlaw. Now it's spider, successfully converted. And then the base object, which is echoed first before the change, it defaults to outlaw. And then we convert it and it becomes spider. Now, the reason the base object defaulted to outlaw is because the default value of kind is 0, and 0 is also the integer value of outlaw enumeration. So conversion between variance and the base object with no kind works perfectly. Child to child conversion. Now that we've got our definitions and variables set, I will demonstrate that child to child conversion for normal objects and inheritance is possible, but only on a quick glance. The conversion is only possible if a variable is first defined as the parent and then given the value of one of its child objects, like outlaw inheritance 2. All this does is fill the values of the object's fields and nothing more. So let's echo both our outlaw variables to see their details. So now let's run this. F6. As you can see, outlaw variable is of type outlaw, while outlaw 2 is of type child enemy. Again, like I said, this is not a real conversion. It just fills the fields that are compatible. Both have. Now let's try converting outlaw 2 to type spider. So outlaw of inheritance 2 type spider, the type to convert to, and then the variable again to convert it. Now let's copy paste the echo. Now make sure you're using compiler setting of gcorg in the config.nims file. Otherwise, with the currently default refc garbage collector, soon to be replaced with gcorg, you will get an object conversion error. Now let's run this. As you can see, nothing happened. Outlaw 2, outlaw inheritance 2, is still of type child enemy, because child to child conversion is not possible. Only child to parent and parent to child conversion is possible. Now lastly, let's try the child to parent conversion. So let's copy paste this and just change to child enemy type and run this. As I said earlier in this section, since we made outlaw 2 as child enemy first and given it its empty value of outlaw, it remained of type child enemy. No real actual conversion for inheritance is possible. Even the compiler will tell you that. There is a way to do this though, by using casts, but this is the subject of another video. Casts in super short version are basically a view into another data type. They are also considered unsafe, meaning you could easily cause problems with incorrect usage. Storing into containers. As I have shown earlier, object variants have a problem with storing its base object along with its variants into containers such as sequences. But inheritance does not have that problem, though I do not see a reason why one would need to do this. Performance comparison. Object variants are faster. Inheritance works best with refs and PTR. At this point, inheritance should be very fast, probably even faster than object variants. But then you are required to use methods. Methods are dynamic dispatch, and it is slow. Therefore, with a complex parent-child hierarchy, you will have many methods, and with many methods, it will be much slower than object variants with procs. Here in the following screenshot are the results of a performance profiler program called WallGrind that I used to get performance results from the earlier object variants versus inheritance code. When to use object variants versus inheritance. Use methods if you want unbounded polymerism. Can add new logic functionality without having to go update a master list of things. Useful if you're expecting to be adding new things all the time, or if you're making a library and want users to be able to make their own kinds. Otherwise, use object variants. Procs use static dispatch. Compiler will match a proc to the first matching object call. With inheritance, if the first appropriate match is the parent, all of its children's calls will be ignored. The parent's call will be used instead. Dynamic dispatch is achieved with methods. The matching will be done at runtime, allowing more flexibility at the cost of performance. Methods will not stop at the parent of inheritance, but find the most appropriate matching child. Okay, that's it for this video. Thanks for watching. Like, share, and subscribe, as well as click the bell icon if you liked it. You can also follow me on Twitter of the same name and support me on Patreon. If you had any problems with any part of the video, let me know in the comment section. The code for this video can be found in the video's documentation script styled with nimib as a form of offline tutorial. Have fun!